Okay, so thinking back to what you know, right, you're looking for the pH now, and you've been told the concentration of the solution. This is a strong base. This is a strong base, so therefore it's going to release a lot of these hydroxide ions. Okay, the hydroxide ions. It will go to completion. So if you add BaOH to water, OH2, you're going to release all of those to make OH minus ions. So think about that and how you can therefore work out a pH. So your equation for pH is minus log 10 of the hydronium concentration. You haven't been given that. So you need the other one. You need the Kw to work out the mystery hydronium concentration, because you know this one, but you want to know hydronium, not hydroxide. So you're going to first of all work out your hydroxide concentration. Then you're going to have to work out your hydronium from that. And finally, part C, you'll be finding out the pH. Okay, so for part A, you need to recognize that the product of the two is constant, and it's set at 10 to the minus 14. So therefore, if you know one, you can find the other. So if we substitute in, just going to bring this up here now, the value for the concentration of hydronium, we know it's going to be 0.005, but because there's two hydroxide ions, it's going to be doubled. So that's the value of OH minus, and that's still timesing by the unknown value for H3O plus, and those two equal 10 to the minus 14. So how could we work out? How do we work out H3O? Alright, so how do you do it then? Last bit, how do we find out hydronium? H3O plus is equal to 10 to the minus 14 over 0.01 if you times that by 2. So that's going to be 10 to the minus 12. Now, if you know your pHs, you'd know straight away that this is pH 12. But you should show it with your formula. So the last step is going to be doing the pH formula. So pH is equal to minus log 10, borrowing this formula over here, minus log 10 of 10 to the minus 12 in brackets. And that will get you the number 12.